Alright guys, in this video we're going to be looking at solving exponential equations that require us using some logs. Before we do that though, there is one property that we're going to look at first because it's going to be required in order to solve these equations, and that's something called the change of base property. So this change of base property says that log base b of n is equal to the log of n divided by the log of b. So I've given an example right over here. Log base 3 of 4. If I use the change of base property, it says that the log of 4 divided by the log of 3 is the equivalent of log base 3 of 4. Now if I enter this into my calculator, the log of 4 divided by the log of 3, I end up with a decimal of 1.26. Of course, there are more decimals. I've just rounded this to the nearest hundredth, 2 decimal places. So we're going to use this property in solving these equations that we're going to look at here. Alright, example number 1, we have the exponential 6 to the x power is equal to 104. First thing I'm going to do is rewrite this as a log. So this exponential is now going to become the log base 6 of 104 equals x. So all I've done is rewrite the exponential in the form of a log, and this was covered in another video. So now what we're going to do is we're going to use that change of base property. What I'm going to do is solve for x. And that change of base property says log base 6 of 104 is equal to the log of 104 divided by the log of 6. So what we'll do is we'll enter this into our calculator. The log of 104 divided by the log of 6 turns out to be 2.59. Again, I am using or rounding these decimals 2 decimal places. Alright, so we do end up with a solution of 2.59 for this equation. In other words, 6 to the 2.59 power is equal to 104. Now keep in mind I did round this, so it's not going to be exactly 104, but it is pretty close, and that's because of the rounding. Alright, example number 2, here we have 8 to the x power is equal to 1,200. I'm solving for x. So in order to solve for x, what we're going to do first is rewrite this as a log. So this exponential is now going to become the log base 8 of 1,200 equals x. So all I've done is rewriting the exponential as a log. Now what we're going to do is we're going to use that change of base property. So it says that x is going to equal the log of 1,200 divided by the log of 8. Again, what we're using here is the change of base property. So if I enter this into my calculator, the log of 1,200 divided by the log of 8, we end up with a decimal of 3.41. Again, I'm rounding my decimals 2 decimal places. So x is equal to 3.41. Number 3, we have the exponential 7 to the x power is equal to 3.5. I'm going to start by rewriting this as a log, and that log would be the log base 7 of 3.5 equals x. Now I'm going to use that change of base property. So x is going to equal the log of 3.5 divided by the log of 7. This is that change of base property. So if I enter this into my calculator, the log of 3.5 divided by the log of 7, I end up with a decimal of 0.64. Once again, I am rounding these 2 decimal places. So again, if I were to replace this x right here with a 0.64, 7 to the 0.64 power would equal 3.5. Again, it's not going to be exact, and that's because I've rounded my decimal. Number 4, we have the exponential 1.5 to the x power is equal to 22. We're going to start off by rewriting this as a log. So this now becomes the log. The base is 1.5 of 22 equals x. Now we're going to use that change of base property. So x is going to equal the log of 22 divided by the log of 1.5. So if I enter that into my calculator, the log of 22 divided by the log of 1.5, I end up with a decimal of 7.62. Therefore, my solution of this equation is 7.62.